Hello and a very warm welcome to my dear students in today's class. Isro has successfully launched the first of the second generation series of the NavIC constellation. NavIC, which is the short form of Navigation from Indian Constellation, is about to get a boost. The roadmap goes like, of course, the news will be discussed. What is NavIC, which was erstwhile known as IRNSS, and the applications as well as the usage of it. What is the highlight of the current launch? What was the need for India to have its own regional navigation system when India could depend on America's GPS or Russia's GLONASS? GPS versus NavIC and the NavIC chip, which is a part of the semiconductor mission. We will discuss the advantages of having our own navigation satellite system as well as the criticisms of the current project. So, ISRO has successfully launched the first of the second generation of the NavIC constellation. This is known as, the first satellite is known as NVS-01 or NVS series. This is pretty heavy, the heaviest IRNSS system or the NavIC system. It weighs 2232 kg and it went aboard on GSLV rocket, GSLV F12. We will discuss that as well from Sriharikota. So GSLV F12 is 51.7 meters in length, 420 tons in weightage, and it's a 3-stage one. It is the 15th flight of the GSLV and it was the 6th operational flight of GSLV with cryogenic stage, in which at a very low temperature the liquid fuel is stored so that GSLV could get a weight advantage. What is NavIC or IRNSS? Like the American GPS, we have our own regional navigation system. It's an independent regional navigation system. That means we depend on our own satellites through NavIC. In order to provide accurate positioning system for merchant vessels, for other usage, even restricted usage as in for armies as well, this was taken into consideration by India and hence the launch of NavIC. The coverage is such that it gives approximately 1500 kilometer of coverage from India's boundary. In miles, we can say it is 930 miles. Alright, and it is there to assist in the navigation of ships in the Indian Ocean so that we do not depend on US owned global positioning system. It provides standard positioning system, our own NavIC, and one more positioning system. We will discuss that. The primary service area is 1500 kilometers approximately from India's boundary. There is also extended service area. This is for restricted usage such as for armies, for navies. It provides the coverage, the extended service area between the primary service and the area which is enclosed by a rectangle. This rectangle is 30 degree south to 50 degree north and to 130 degree east. Okay, so remember all this. Then if we talk about the other positioning system and how it works, the NavIC satellites where they are above our Earth, we have to ensure that 3 are in the geostationary orbit and 4 are in the geosynchronous orbit. Remember that. 3 in the geostationary orbit and 4 in the geosynchronous orbit, as in the original ones, not the 8th one. Then, what is the difference between geosynchronous orbit and geostationary orbit? Remember, in geosynchronous orbit, by the name synchronous, we can understand that this satellite seems like it is moving along with the Earth. So it can be put at any inclination, whatever the inclination might be, but it synchronizes with the rotation of the Earth. This is the beauty of it. As Earth revolves on its axis, rotates on its axis in 23 hours, 56 minutes and 4.09 seconds, this is what the geosynchronous satellite also does. And because of this, it seems like it is in a fixed position. As you can see, this is at any inclination. Here is the satellite, and because it is moving along with the Earth, it seems like if I am standing here and I am looking at the satellite, it seems like it is fixed in position. And because of this, what happens, as we want to talk to our friends and to talk to our family in a real-time manner, and that is why this geosynchronous satellite is used for telecommunication and remote sensing application, so that it gives real-time information, because the Earth as well as the satellite is moving at the same time. Then we talk about geostationary orbit. It is in the same category at geosynchronous orbit, but they lie on the same plane as equator. This is the equator and this is the orbit, and it seems like that they are lying on the equator. And it is parked over the equator. That is why it can have a constant look at one area for a longer time. And that is why it is used for weather monitoring as well as search and rescue operation for beacon as well. And if we compare these two, geostationary orbit over the equator, geosynchronous orbit at any inclination. And our satellites are placed in such a manner that they are usable for telecommunication, for real-time navigation, as well as weather monitoring, search and rescue. Now, the project approval came very early as May 2006. And it was supposedly to be completed by 2011. But because of certain delays, the first satellite could be launched only on 1st of July 2013. When we reached the 8th one, it became 2018. We could have 7 satellites only, but one satellite became defunct, the IRN-SS-1A. So in order to replace that, we had to launch another satellite. Now in 2020, IRNSS or NavIC was recognized as a member of the Worldwide Radio Navigation System by International Maritime Organization, which is a specialized agency of the United Nations, so that the merchant vessels can use the NavIC system easily. Now, India's IRNSS is now part of the Worldwide Radio Navigation System. By 2018, we had 8 satellites, of which one was defunct, so 7 satellites were there. And it took 2 years to get the entire process resolved. That in 2020, it became a part of the entire system. Now, it provides 2 kinds of services. Standard positioning system, this is available for everybody, and restricted services, which provides encrypted service so that it could be used for authorized users only. And now it is expected to provide a position accuracy of better than 20 meter in the primary service area. That means 1500 kilometers from the Indian boundary. Applications include terrestrial, aerial and marine navigation, disaster management, vehicle tracking and fleet management. It is also important that we integrate them with the mobile phones, precise timing, mapping and geodetic data capture, terrestrial navigation for hikers and travelers, and visual and voice navigation. So these are the many points. If it is asked in your preliminary examination, I have already told you how geosynchronous orbit and geostationary orbit satellites work. So by putting that concept into knowledge, you can understand what all we can achieve through the NavIC system. Now the current highlights are such that earlier also rubidium atomic clocks were used in the navigation satellite system. So as they are getting older, we have developed our first indigenously built technology, rubidium clock and atomic clock. And this has been developed by Space Application Center of Ahmedabad. And what is the purpose of rubidium atomic clock? It provides a satellite-based positioning system. It is actually a workhorse of the satellite. How much time a place is away from the satellite can be measured by the rubidium atomic clock, because it sends signals, and how much time the signal takes to come back to the rubidium atomic clock the entire time is calculated with the help of this particular clock, and after that only we can ascertain what position is where. Okay, so rubidium atomic clock has also been developed, and this is the simplest and the most compact of all. That is why it is lighter, and it is much appropriate to use them for satellites. It uses a glass cell of rubidium gas. Rubidium gas changes its absorption of light at the optical rubidium frequency, and that is why it is used in satellites, because at that level also it can function very well. Rubidium, it can be liquid at room temperature, and it is a soft silvery white metallic element of the alkali group. It is the second most electropositive and alkaline element, and it ignites spontaneously in air and also very violently reacts in water. So if it is asked in your preliminary examination, you can answer these questions well now. Now, another highlight is that we have an extra band. Already the erstwhile ones had L5 and S frequency signal bands, which exist in these particular satellites, the earlier ones. L1 band is also there now, which is among the most commonly used for GPS systems. So now navigation will become much easier. because it will be available for wearable devices such as smart clocks and personal trackers as well. Smart watches, which I'm trying to say over here. Now, the next portion is that it will have a longer mission life. The erstwhile had only 10-year mission life. This will be longer, and we would want much longer because it takes a lot of cost for the logistics to be developed to transfer the satellites here and there. Now, as I told you that the project got approved in 2006 because in 1999 Kargil war, during this war, America wouldn't provide us the proper information of GPS. America went to Russia, GLONASS. Through GLONASS, Russia did provide certain information, but not the full one. So it could have caused lesser harm if we had our own navigation system, although there are no official records of this. So because of this particular incident only, we thought we should have our own navigation system. An indigenous satellite-based augmentation system is also there, which is GPS-aided geo-augmented navigation, or GAGAN. This is for the civil aviation industry and also for Indian Air Forces. See, differences and similarities. While American GPS can get you within 20 meters of your target, NavIC can get you closer within 5 meters. GPS can be used anywhere globally. For India, for NavIC, it is not so, because we have our regional navigation system 1500 kilometers or 930 miles from Indian boundary. Also, after Galileo of European Union, this is our second program. This is the second program in the world which has a messaging interface facility embedded in satellites. So if any mishappening happens with respect to cyclones or anything, messages can also be sent with the help of these satellites. Alright, cyclone warning in coastal areas. This is the application. Other points are like the NavIC chip which has been developed. It will make our NavIC system certain advancement, such as Bengaluru-based space technology company has made this NavIC chip. This is indigenously designed and also India's first fully designed and developed processor. It was designed by IIT Kharagpur incubated ELINA Geosystem. It could be asked in your prelims, that is why I'm giving you this information, which could be used for transportation, disaster management, agriculture as well as defense. So these many things can be achieved. Other than this, NavIC receiver chipsets. This is a part of the semiconductor mission, which was launched in December 2021 with an outlay of 76,000 crore. There is a dedicated institution for Semicon India program as well. So that investments are there and India becomes digitally empowered, because the total exports for electronics and item mobiles crossed 75,000 crore in 2022. In 2014, total electronics production was worth 1 lakh crore. By 2025, it will be 25 lakh crore. This is our prediction. So India should not get embedded in the chip war between China and USA, could have our own chipsets. Alright. Now, advantage is that India is the only country that has a regional satellite-based navigation system. There are 4 global navigation satellite systems: American GPS, Russia's GLONASS, and of course, I'm not going to read this, European Galileo, and Chinese Beidou as well. Japan has 4 satellite systems that can augment GPS signal over the country, and there is work underway to get our GPS system integrated with countries such as Japan, Russia, and France. NavIC signals are actually better to be captured in dense areas, forested areas, disaster-struck areas, because the signal come to India at 90-degree angle. So these are the reasons why NavIC is the best for us. Then the current issue is that the current development is not very satisfactory. In order to integrate NavIC system into the daily lives of the people of India, India is not doing very well. Encouragement is not being given because cabinet cleared funding of rupees 200 crore to do this. But the application started only in March 2017. For these many things, navigation system, NavIC, can be used. Even some of the cell phone chipsets, such as the ones built by Qualcomm and MediaTek, they integrated NavIC receivers in 2019. More is to be done. So I hope you understood this topic well. If you have to get a PDF of it, you can search for me on a Telegram channel by the name of Pooja Dwivedi, StudyIQ. You can also scan this QR in order to reach me at Instagram in order to if you have any sort of questions with respect to this particular class. Okay, so I hope this segment helped, this class helped. I shall see you again soon. Thank you so much for watching.